Scattered across the cosmos, galaxies aren't merely drifting as the universe expands. Instead, they are being drawn together by a hidden force, an unseen hand shaping the very fabric of space. Something else is happening, something extraordinary. Across billions of light years, an invisible force is tugging at the cosmos itself, pulling thousands of galaxies, including our own Milky Way, toward a single mysterious point. This is the Great Attractor, a gravitational anomaly of such immense power that it overrides the universe's expansion, pulling entire galaxy clusters toward it at speeds of over 600 kilometers per second. Yet, frustratingly for astronomers, this cosmic behemoth lies hidden behind the densest part of our own galaxy, in what we call the Zone of Avoidance. What could possibly exert such tremendous gravitational influence? And what does it tell us about our place in the cosmic web? Join us as we explore one of astronomy's most compelling enigmas. The first hints of this cosmic mystery emerged in the 1970s, when astronomers noticed something peculiar. Galaxies weren't just moving away from us with the expanding universe. They were also exhibiting unexpected, peculiar velocities in a specific direction. By 1987, astronomer Alan Dressler had given this phenomenon a name that captured its allure: the Great Attractor. Detailed observations revealed that our Milky Way, along with thousands of other galaxies, was being pulled toward a point in the constellation Centaurus at the remarkable speed of 600 kilometers per second, fast enough to travel from Earth to the Moon in less than 7 minutes. But there was a problem. The Great Attractor lies directly behind the plane of our galaxy, in a region astronomers call the Zone of Avoidance. Like trying to see through a dense fog, the gas, dust, and countless stars of the Milky Way's disk obscure our view of this crucial region of space. For decades, this cosmic mystery remained tantalizingly out of sight. What we do know is that the Great Attractor lies approximately 150 to 250 million light-years from Earth, a distance so vast that the light we see from it began its journey when dinosaurs still roamed our planet. The mass required to exert such gravitational influence is staggering, approximately 10 quadrillion times the mass of our Sun. To put this in perspective, that's equivalent to 100,000 Milky Way galaxies concentrated in a relatively small region of space. Using X-ray observations that can penetrate the Zone of Avoidance, astronomers have identified the Norma cluster as the likely heart of the Great Attractor. This massive galaxy cluster contains numerous ancient galaxies, many of which are colliding with their neighbors and emitting powerful radio waves, a cosmic demolition derby playing out over millions of years. But the Great Attractor isn't a single object. Rather, it's a complex gravitational landscape, a region where the cosmic web of matter has formed an unusually dense knot, creating a gravitational well that affects everything around it. In 2014, our understanding of the Great Attractor took a dramatic leap forward. Astronomers mapping the flows of galaxies discovered that the Great Attractor serves as the gravitational focal point of something much larger, a vast supercluster of galaxies now known as Laniakea, Hawaiian for immense heaven. Laniakea contains over 100,000 galaxies, including our own Milky Way, and spans an astonishing 500 million light-years. Within this immense structure, galaxies move like rivers flowing toward a central sea, the Great Attractor. This discovery fundamentally changed our cosmic address. We now understand that our Milky Way isn't just part of the local group of galaxies, which itself is part of the Virgo supercluster. Rather, all of these structures are mere components of the much larger Laniakea supercluster, with the Great Attractor serving as its gravitational heart. Visualizing these cosmic flows reveals the true nature of our universe, not as static collections of galaxies, but as dynamic streams all flowing along gravitational contours shaped by the distribution of matter across space and time. The story of the Great Attractor continues to evolve. In 1992, some astronomers suggested that its apparent mass might be partially explained by a statistical effect called Malmquist bias, which can lead to overestimation of distant objects' masses. More significantly, observations in 2005 revealed that beyond the Great Attractor lies an even more massive structure, the Shapley supercluster. This cosmic giant appears to be pulling on the Great Attractor itself, creating a complex gravitational landscape where our galaxy is being pulled toward the Great Attractor, which in turn is being pulled toward Shapley. In 2017, astronomers added another piece to this cosmic puzzle with the discovery of the dipole repeller, a vast, relatively empty region of space that appears to be pushing galaxies away from it, just as the Great Attractor pulls them toward it. Our Milky Way thus finds itself caught between these cosmic push and pull forces, like a leaf carried along converging currents. These discoveries highlight how much remains unknown about the large-scale structure of our universe. The visible matter we can observe directly simply isn't enough to explain the gravitational effects we're witnessing. Dark matter, the invisible substance that makes up roughly 85% of the universe's mass, must play a crucial role in these cosmic structures. The Great Attractor remains one of astronomy's most intriguing puzzles. It challenges our understanding of how matter is distributed throughout the universe and how structures form on the largest scales. Future telescopes operating across multiple wavelengths will allow astronomers to peer more clearly through the Zone of Avoidance. Meanwhile, gravitational wave detectors may eventually detect ripples in spacetime caused by the interactions of supermassive black holes within these enormous structures. What we learn about the Great Attractor and similar cosmic structures will refine our understanding of dark matter, galaxy formation, and the ultimate fate of our universe. Each discovery brings us closer to comprehending our place within the cosmic web. The Great Attractor reminds us that even our galaxy, with its hundreds of billions of stars, is but a small participant in a much grander cosmic dance. We are being carried along vast rivers of galaxies, flowing through space toward gravitational confluences shaped by forces and structures we're only beginning to understand. As we gaze out at the night sky, we're not looking at a static tableau of stars and galaxies, but at a dynamic, flowing system, a cosmic web where everything is connected by the invisible threads of gravity, stretching across billions of light years. In this immense cosmic ocean, we continue our journey of discovery, humbled by the scale and complexity of the universe, yet ever more determined to unravel its deepest mysteries.